Hi all, I'm Vladimir, you're watching the BimDoc channel. Today we'll be talking about chip tuning of BMWs. That's a very interesting topic and you will not find that kind of information anywhere online freely available. So make sure to subscribe to my channel and stay tuned. Let's go! So what is the chip tuning? As you probably know, chip tuning is increasing the power of your car. Is it BMW, Audi, Mercedes? Actually, it doesn't matter. In nowadays chip tuning world, it is divided into different stages for more convenience and better understanding. By chip tuning your BMW, you'll increase power and torque of your engine and or a gearbox. So, I told about the stages, how it's divided. Basically, stage 1 chip tuning is software modification only. During the stage 1 chip tuning, information from the engine ECU, is it diesel or gasoline, it doesn't matter, is being read out, it's being modified and written back to the car. No additional modification inside the car is needed. So basically you'll just increase the power of your engine and or your gearbox by just changing the software inside it and the way how it operates. The stage 2 chip tuning requires software modification and hardware modification. So basic software modification is very similar to stage 1. You read out the information from the engine and or gearbox ECU and write it back. Before that, that information needs to be modified, of course. It includes modifications in outtake of your engine. Basically, you have to install downpipes, remove DPF or something like that. In addition, sometimes in the stage 2, the bigger intercooler is required. Bigger intercooler can cool your air down more efficiently, and that's why the same amount of air can include way more oxygen that's necessary for engine working. Stage 3 modification includes, of course, software modification and hardware. In addition to stage 2 modifications, you have to make, in addition, exchange of your turbocharger. Basically, you will install the bigger turbocharger, and in order to that to work properly, the software modifications has to be made. Stage 4 modification include, in addition to software changes, all stage 1, 2 and 3 hardware modifications, and in addition to that even more changes inside your engine. So basically stage 4 is very expensive and can be done only at high-end professional chip tuning companies. What stage would I recommend to you? If you have a regular car, diesel, gasoline, you are using it not on track anywhere, so basically stage 1 is a good modification. During that, no hardware changes is needed. You will get way better performance from your car, and even the consumption of your gasoline or diesel might even decrease. If you are a bit more BMW enthusiast, yes, stage 2 maybe. Stage 3 definitely not recommended if you don't have any M performance cars. And stage 4 is way too expensive and not reasonable at all. You have to understand that each stage will give you some additional power and torque, but the bigger is the stage, the less it gives to you. For example, making the stage 1 will add to your engine, let's take for example 30 kilowatts. Stage 2 will add something around 10 in addition to that. Stage 3 even less, and stage 4 even less. So you'll think, so what the point of making like stage 3 and stage 4? If you are drag racing, then milliseconds, it's important there. But during the regular life, stage 1 and stage 2 is totally enough. Today I will show you how to chip tune your BMW, and we will be making that on that beautiful Cabrio. It's E93, it's 2008. Yes, it's not the newest car, but same principles will apply to all other brands as well. I would divide the process of the chip tuning into 4 sub-steps. The first step is running the full diagnostics of the car, because you have to be really well aware of the condition of the car you will be working with. That's the step 1. Step 2 will be reading out the information from the engine ECU and sending that to the special guy who will modify that. Step 3 will be writing that modified information back to your ECU. And step 4, yes, correct, diagnostics again and running some performance check. There is not a single tool in the world that can chip tune all the possible cars in the world. Basically, for each car, for each modification, for each engine, you will require a certain set of tools to work with. That's very important to understand. Today, as I told, we'll be working with the E series. It's 2008 and that's our Cabrio. So 93. It has 2-liter diesel engine. It's N47. And to work with that, we'll need, for step 1 and step 4, I will use ICOM Next in order to run the proper diagnostics of the car. And for step 2 and step 3, reading out and writing, I will use the CAS programmer in order to read out and write modified software. To work with another BMWs like F and G series, you will need different tools. Those tools will be needed at step 2 and step 3, basically reading out the information and writing information back, because one tool cannot work with all the BMWs. I have already made a lot of chip tunings to F and G series BMWs also, so if you are interested in that topic, make sure to leave a comment about that, write the model of the car you're interested in, and also hit the subscribe button if you haven't done so. Also, if you like my content, I would really appreciate if you will hit the like button, so that will help my channel to grow. So let's continue with working with that BMW. One more very important thing when you're doing chip tuning or working with the car, you will need additional power supply. So basically you need to hook up those crocodiles to the car in order to supply that with efficient amount of electricity, because in the process of 2 and 3, basically reading out information and writing information back, additional power supply is must. Without that, you'll probably fail. Let's proceed with step 1. The first thing I would recommend you to do is just to start the car and to see if it's working at all or not. Just running the car. It's important to see that no errors left. Yes, there is one error of the lighting system. Actually, it doesn't matter. The thing I would like to see, there is no errors with the engine. I have hooked up additional power supply to the positive and negative outputs. So as you can see, the car is consuming around 24 amperes at 14 volts at the moment, and that will be more than enough to work with that car. We'll run diagnostics while the power is connected. Of course, it will be not enough just to see if there's any errors inside the car with with your eyes. You have to run the proper diagnostics using the ISTA. So that's why you can see the display of my laptop. There are several errors. We can see there is exhaust gas back pressure sensor and so on. That's because the particle filter is removed on that car. But cooling flap actuation system, yes, there are some errors present. So it's very important to save a picture of the current errors. So after you work, you will it's easier for you to diagnose and understand what you have done with the car. Is it proper job or not? So basically, in ideal world, after we will be finishing our job, there should be no errors present inside the engine ECU. We will not fix today the other errors, for example, something with the lighting system like brake light fault and so on. It's not our case today. But making the screenshot of that is must. We'll also try to delete those errors, and we'll see what of those errors will appear and disappear. It requires to switch off the ignition. No problem, let's do that. And we can see that 10 errors are still present. So that's step 1 is very important one. You have to understand with what you are working with. So inside the engine we have the cooling flap air system activation, and we have that error still present. So it means that there's some physical error present in the car, and we should not fix that with the software. We have to fix that at the hardware level. All the rest, actually a lot of different errors, but they are not important at our current job. So basically we have run the diagnostics. One more thing, I need to check the condition of the particle filter. I know it was removed, but I have to check that. Charging operation values, not that. Exhaust emission system. I need to know if the regeneration of the particle filter is still active or not. So basically back pressure is 0 at the moment. Yes, engine is not running. Mileage since regeneration, that one. Regeneration not requested, yes, that's a good one. And enable not requested, yes, I'm totally agree with those values. That's good. Let's proceed to step number 2, reading out the information from the engine. For the step 2, another tools are needed, so we will be using CAS, because that's E-Series, it's kinda old car already, and that programmer will deal with that car very nicely. Let's just connect that to the OBD socket and launch our computer, and I'll show you where to click and why to click. So our power supply is still connected to the car. That's our CAS connected. It goes with the USB to the computer, and another side of that CAS programmer goes directly to the OBD2 socket. Let's launch the program and see what's inside there. As you can see in my chip tuning arsenal, there is way more different programmers, but we'll use that one today. Because as I told you before, each car needs different approach. You have just to know where to use what. And if you know all the process, that's really straightforward. So let's choose car, and that's BMW. Actually, that will be our 3 Series E93. And over here we can see it's automatic transmission, it's AT and 2-liter diesel. It's N47, 130 kilowatts, and it shows it is EDC 17 CP there. And what does it mean? It means that with the CAS programmer I will be able to read out that, but while I'll be writing that back, I will fail. Because that current programmer will not be able to work with that specific car. That's a pity, but actually we have workaround for that. We'll just use another programmer. No problem, it happens because you cannot know ahead all the nuances that might come into play while you'll be working. That's why you have to have a big variety of the tools in your disposal. Give me a couple mics, I'll make another preparations and we'll continue. So, due to change of the situation, I have to use another programmer. I will use the BitBox. Basically, the BitBox is the software inside my computer, and that's the USB dongle in order to activate that. Because we'll be working with the E-Series, we'll need some kind another adapter that's open port adapter, Tetrix, and we'll connect that to the car and we'll be able to read it out. So let's read out the software using another tools, and then I'll show you how I connected everything. I will need another program. Let's open again that magic folder where it's called Chiptuning, and let's choose the BitBox software for that. Actually, I would have to think about those small details earlier, because that car is 2008, yes, but it has N-Series engine inside, and N-Series engine require EDC 17 ECU and not EDC 16. That's why there's even like not a single chance I would make with my CAS, what I was thinking about. But that's called experience. Okay, let's choose the cars. BMW, we need 3 Series and N47 2-liter diesel, and 2-liter diesel. Which one of those you have to choose, because you can see there's 3 N47 engines, but they're different modifications and they are with different families. I guess it should be CP02, because I have done the similar car a year or two ago. Let's choose that one. Let's try to identify that. Ignition has to be on. It shows success. It shows the CPU is CP02. Let's try to choose another one, and let's see what it will show us. So basically, let's choose intentionally the wrong one. So that one. That's EDC 17C41. Let's choose that one. Let's click identify. OK. And actually it shows us that it's the wrong family because CP02 is installed there. So I was right before, and at the first time we have chosen the right. So let's choose the right again, BMW 3 Series and CP02. As you can see, it's EDC17 CP02, so that's the same ECU, but those are also different modifications of that goes to the different type of engines. That's why the chip tuning is not just a straightforward process. You have to understand at least something about the cars and how those cars are built. Let's press OK and identify. Now it shows it's OK, that's good, and let's read out the information that's inside the ECU. That program requires internet connection in order to work. Basically, a lot of nowadays programmers require internet connection. That's the protection against the piracy. And the software is being read out. So let's save that to our desktop. And I usually prefer to make a lot of different information there. So basically that's E93, it's 2-liter diesel, it's N47, it has EDC 17, correction 17 CP02 ECU, and that software is stock and read out with the bitbox. So that's the proper way of the naming convention of the read out files. Well, chip tuning. That's success. Let's switch off the ignition. And okay. So basically, yes, that's it. What we have to do next? We have to send that readout software to the special guy who will calibrate, make all the needed modifications inside the ECU, and then we can write it back. While software is being modified, I promised you to show how I connected that new device. As you can see, it goes inside the OBD2 socket with the USB cable through the USB-A to USB-C converter inside my laptop, and the dongle is also connected there. And basically that's it. All the rest of the process you have already seen. It's very important to understand that chip tuning is such a process that doesn't like rush. We have read out the information from the engine ECU, we have sent them to the special guy who will modify that in order to increase the power and torque of our engine. But that guy, he also needs some time in order to make his job properly. If he's available, it's usually needed around 1 or 2 hours in order to modify the information inside the file we have read out and sent to him. If he's not available, we have to wait a bit in the queue. That's why it's usually a good process to divide chip tuning into 2 parts. One day is reading out, and the end of the same day or another day is writing the information back. That's why that process takes some time. And while you are waiting, you can drink some coffee or, for example, deal with another BMWs. Main message is never just waste your time. Do something that will educate you, read something, watch some useful videos, subscribe to useful channels like BimDoc and so on. While we are waiting for our software to be calibrated, let's not waste any time. I'll show you one useful resource where you can see how many gains you will get after the chip tuning. It's not advertisement in anyhow. That's just a resource one of the resources I'm using daily to get some information. So that's one of the resources you can use. It's totally free. That's the bigger chip tuning company. You can order software directly, for example, from them, or you can just have a look what gains you will have and so on. Different languages. Let's switch to English. And for example, let's have a look what gains we will get from stage 1 chip tuning of today's BMW. Let's choose BMW. We need its 3 series. Year. The year is, actually you can see 2005 and 2010. Yes, it's written E90, E91 only, but actually E92 and E93 is exactly the same because the engines that goes there are the same. Engine type, we have 2-liter diesel, and we have to know the power of that. And view gains. As you can see, the engine will have additional 38 horsepower and plus 17 Newton meters. And as you can see, The engine that is installed here is EDC 17 CPO2, the ECU. Remember, we have exactly read the same one out. So that's the way how you can check all the gains. For example, let's check. Lately I was chip tuning my G30. That's 5 series. So basically G30, I have engine 3-liter diesel, that one. And let's see the gains on the G series for the stage 1. So 45 horsepower and plus 100 Newton meters. Those are really good numbers. So the acceleration of my G30 should be around like 5 seconds to 100 kilometers per hour. I have not made any measurements yet because in Estonia it's still ice and snow outside, but when there will be no snow I will have my nice summer tires on 20-inch rims. We will make those measurements also. It's been around 1 hour waiting time for me and just a seconds for you. I have received the modified software and now we can proceed to step 3, writing the software inside the car in order to make stage 1 chip tuning. Let's go. I have connected all back together in exactly the same sequence I have shown before. So basically the programmer goes into the OBD2 socket, the USB cable goes inside the laptop, and laptop has to be connected with the internet, and that's it. Let's open our chip tuning software. And basically writing back the software is very similar to reading that. We have to make all the same steps. The difference is that we are writing the software back. But the bigger difference is that's the way more risky step. If something goes bad during that step, we'll not start that car anymore, at least today. So again, let's choose the proper car. So that's 3 series, 2.0 diesel with the right ECU. That's EDC 17 CPO2. Let's identify the car. The program asks to turn on the ignition. Yes, ignition should be on. Power is still connected. I even haven't disconnected the power in order to charge the battery a bit more. So it has been read out. Let's proceed with write. I have saved the modified software to my desktop. It should be here. So basically, yes, it's stage 1 and DPF off. Basically, I can make whatever combinations you need, DPF, flaps, whatever you just ask, and I offer you. It requires the original file for checksum calculation. Let's load that. And soon the writing process will begin. It takes some time, not too much. Ignition should be on. Let's just double check. Yes, I can see ignition is on. It's a warning sign, so if you choose the wrong software to write inside the ECU, you will damage it. And basically after that the car will not start anymore. So that's not good. So now the car is being entered into the programming mode and the programming itself started. So you can see the process now. Basically the car is in the programming mode. The programmer is working. Also the laptop is working. You can see information goes in there. The power is still connected. We cannot do without that. You can see the consumption there is 32 amps at the moment. That's why power is important. And now we have just to wait while the process is running. The process is really straightforward. Basically it takes around 5 to 10 mics in order to write back the software inside the ECU, and then the job will be done. Okay, it will be almost done. We have still to make the final check if everything is really okay with the car and we have achieved the result we need. Programmer will ask sometimes you to switch on and off the ignition. Just act accordingly and that's it. The biggest advantage of that process, writing the software through the OBD2 socket and reading it out from there, is the convenience. Basically, you are paying for your time. Those tools cost more because of the convenience, but there is some downside also. While that process we are reading the software from the engine ECU, we are not getting the full dump, basically not the full portion of the software that's available there. We are reading only a small part of that. The problem is that without the small part, while we are writing that, if something goes wrong, we don't have the full picture of that, and basically the car will not start, and it will be like almost impossible to recover that issue afterwards. That's why there are some another programmers that are able to make the full copy of the ECU. Yes, working with those require taking out the ECU, require sometimes disassembling the ECU in order to get the full access to the processor and reading out all the information. But in that way you are wasting more of your time, but you're getting the guarantees that if something goes wrong, you have always the full dump, you can write it back, and basically that's your protection. It's very important to understand that not all ECUs that are declared in some programmers will handle those. For example, at the beginning of the video, do you remember my intention was to chip tune that car using my CAS. The EDC 17 CP2, the ECU of that engine on that car was declared in my programmer that it will be able to handle that. But believe me, I know that it will fail. It will be able to read the software, but while writing it back, it will definitely make an error. I have done those steps before. That's why using the right tools is essential. But even having all the tools, it doesn't mean that you are fully protected. Believe me, I also sometimes have major fuck-ups, sorry for my language, but basically just spending the whole night in the garage, afterwards trying to recover the car you have just bricked. It's not fun at all, so be really cautious about that process. Some message appeared there. Basically it shows us to turn off the ignition and then press OK. You have to do exactly in the same sequence. So we have to turn off the ignition, wait a bit, and only then press OK. It is important to make everything in the right sequence, otherwise you will fail. Soon the program should write that turn on the ignition again. And now it writes turn on and only then press OK. You have to do exactly in the same sequence. Turning on the ignition. As you can see, ignition is on, engine is off. We're waiting a couple seconds and pressing OK. Now the process can continue. The writing process has been finished. Program tells us to turn off the ignition and wait 15 seconds before trying to do anything. So let's just turn off the ignition. We can even take out the keys. So nothing more, and let's wait a bit. You might wonder why it's important to wait, why we cannot just start the car. Because while we are writing the software, we have been making modifications inside the flash part of the memory. Flash part is also connected to the EEPROM part, and only after we turn off everything, wait a bit, it gives the time, the ECU time to process all the information and recalculate all the checksums, and while we'll be booting up everything up again, only then we can achieve the result. Before running the engine, I will make some initial checks using the same program. Basically, we can read out the DTC, those are error codes. Ignition is on, pressing OK. It says that count 1, the code with that error, and unfortunately no description. No problem, we can try to clear that error. Let's press clear. And let's read the errors again. We are reading the errors, basically exactly the same error. Remember, while we were making the diagnostics with the ISTA, we saw one error inside the engine ECU. I guess it should be the same one. So let's disconnect everything and check if the car starts. That's the most important process. It's not allowed to start the car while our power supply is connected. We have to disconnect that. Before that, let's turn off the ignition. Let's go disconnect our power supply. Let's turn it off first. Let's wait until all the lights will shut. And when that's done, we can disconnect the power supply. Lights are off. Let's take the minus off. And let's take the also plus off. So that's it. Let's go start the car. Now the critical part, will the car start or not? Turning on the ignition, pressing the brake pedal, and yes, the car is able to start. That's a very good sign. And now it's time for part 4, diagnostics and performance checks. Because in Estonia it's still cold outside, ice and snow, I will not make performance check outside because there is no point. There is just not enough grip between the wheels and the tarmac in order to make a proper performance check. But I will make the full diagnostics again. Let's connect our ISTA and see are there any new errors inside there. And I'm running the diagnostics again in order to complete the step 4, because that's also an important step. When you receive the car, you have to know in what condition it is, and when you're giving the car back to customer, you have to make a full report. So basically, your car has that, and I have fixed that, and that. That's the way how it should be done. So let's see, we have 25 errors present. That's totally okay because we are programming the car. As I can already see, basically the cooling air flap activation is the same problem. Remember, we had exactly the same problem before we were working with the car. That's why I can 100% tell that's not the problem of the software we have modified. Otherwise, if I was skipping the step 1 in order to save some time, now I will be inside the struggle. So basically, is that problem caused by me, by my chip tuner? Have I done something wrong, or that's just the problem with the car? So that's why step 1 and step 4 both are critical. Let's delete the fault memory. At the moment, I'm not connected to power supply anymore. Why? Because my intent is to run the engine a couple times to make the full process and to see if everything is okay or not. That's why I'm not connecting the power supply. Because I'm in my garage, it's kind of small box, I cannot run the engine all the time. If you have made any ventilation system that can take out the exhaust gases, yes, you can run the engine all the time. But not during the programming process. And we can see that we have the 10 errors present. Basically, that's exactly the same situation as it was before. So, cooling air flap system activation, and that's it. Let's also have a look what is that system and why it can be caused while we're still waiting for the client to arrive and pick up his car. Basically, radiator shutter, it's that one. Okay, that one. So basically, those shutters in front of the radiators, that system is not working properly. Either there is something is disconnected, or there is some any other fault. That would be just nice to tell to the customer so he knows what to fix next in his car. It's important to understand, today we're making stage 1 chip tuning. That's why no additional extra performance measurements are needed. Why? Because all the BMWs that come out from the factory, they have very similar characteristics, at least inside the same chassis and the same engine. That's why the guy who is modifying the software, he already knows all those parameters. He has tested already those different combinations of charging air, amount of fuel, and so on the dyno stand in his office, and that's why he can work with the cars not even seeing those. Some more fancy stages like stage 3 and stage 4, they cannot be done alone without like seeing the car. You have to run the car on the dyno stand in order to measure the performance, the torque and the power that comes from the engine to the wheels, how much do you have. Then you have to modify the software and modify it again accordingly until you achieve the result that you really want. That's why all the further stages like stage 3 and stage 4, they are way more expensive and at my estimation are not needed in just regular daily usage. Because I always prefer to make the job done properly, let's investigate what's wrong with those radiator shutters and why they might not work. Making like just really quick view, we can see, yes, this is the grill and we can see the radiator there. It's better visible here, but you can see actually there are no shutters left. I guess that was the modification made to that car. Those shutters were just removed and disconnected from the system. That's why they're showing the error. Is it a serious problem not having those flaps, or you have to fix that urgently? I would say it's not a serious problem. The only thing that it will affect the temperature, working temperature of the engine during the colder periods, especially while standing still and just running the engine idle. On the go, while you are driving on the highway during the summertime, it gives even better cooling. During the winter time, it also should be not a problem if your thermostats are working properly as they should. Thank you for seeing this video to the end. If you're interested in the chip tuning topic, just leave a comment about that. Just for information, chip tuning of the E series cannot be done remotely, but there is no problem with chip tuning the BMWs of the F series. It's totally doable remotely, so if you have F series BMW, just feel free to contact me, and the chip tuning online is also available. Hit the like if you did find something interesting about that video, and see you next time. Bye.